So the next thing is there are three kinds of stations. Some are called TIM stations. TIM stands for Traffic Indication Map. Now all of this actually is new, and what I'm seeing is that this was all in this traffic indication map. First time I learned about it was in WiMAX. Before WiMAX, I didn't know about it, but now in WiMAX they have a traffic indication map. Basically in WiMAX, and we will talk about that when we come to LTE, there is a map which tells you when you are supposed to listen, when you are supposed to transmit. Right? So the same thing is here. So in the beacon there is a map which says number 1 you can transmit in the slot number 13, number 2 you can slot number 5, so on and so forth. Right? That way everybody transmits clearly whenever they need to transmit, and there is no contention. Right? So these stations which can do this, they are called TIM stations, Traffic Indication Map stations. They listen to the beacon and transmit accordingly within a restricted access window. So there is a window which is reserved. Restricted access means only if you have permission you can transmit, right? So during that window, TIM stations can traffic and they can transmit, and this is called high traffic stations because these guys are sending very high rate. If you are sending low rate, then you have two kinds. One is periodic, so every 5 minutes you are going to do something. Every 1 day you are going to do something. So they are non-TIM, but they are periodic. So they know that they are going to do this every 5 minutes, or they are going to do this every 1 day. So they can specify that, okay, this is my temperature today, and I will see you tomorrow. Right? So they use they do not listen to beacons. They just go to sleep for a whole day, and then they come up. They already told you that they are going to be sleeping for a day, so they will come back next day and transmit. And so they don't listen to the beacons. And very low traffic. And then there are people who are even less. They don't have a particular time because they're not periodic. They might be event driven or whatever. So they send a poll to the access point and get a transmission opportunity in response. So they say, hey, I want to send something. I want to send something. So they wake up and they say, I want to send something. And when the access point gets it, then they say, okay, all right, now you can speak. So these are unscheduled stations. So three kinds of stations: TIM, non-TIM periodic, and unscheduled. Unscheduled is whenever you wake up, fine. Yeah.
Unscheduled is as well a non-TIM station.
Non-TIM has a periodic thing, so the access point expects, and they actually get a guaranteed window. They get a periodic restricted access window.
No, I mean the very low traffic is also a non-TIM station.
So non-TIM are in two kinds. Again, let me say, periodic and non-periodic. Okay, that's all there is difference. But periodic you get guarantee. Non-periodic you don't get a guarantee. You just have to try. All right. So now we know three kinds of stations. So now we can say how the channel access works. For TIM, each station knows what segments they belong to. So I got to explain what segment. Let me see. Let me skip this slide and go to segments. And so let me just explain segmentation first. Since there are going to be 8,000 stations, if I put a map where station number 1 you speak this and that, or station number 3 I have a packet for you, station number 4 you can speak, the beacon will become so big. Right? So we don't even have place for 8,000 bits, let alone anything more than a bit for 8,000 stations. So how do we manage 8,000 stations? They wanted to manage 8,000 stations somehow. Okay, 2,000 is too low, 8,000 is good. So they said what we will do is we will divide them into 4 pages of 2,000 each. So you are on page 1, you are on page 2, you are on page 3. So the beacon will come for page 1, you listen to that, and that is just like before, 2,000. And page 2 beacon is for this thing, and page 3 beacon is for this. right? So every station is in a page, which is called a segment. So we divide the whole network into, it's like a big class we have in WashU. We divide them into sections, right? So you are in section 1, section 2, section 3, section 4. And so that is what the pages are, that is what the segments are. Alright? And so there is a separate beacon for each segment. So there is a segment, there is a beacon. So you see here, there is a beacon for segment 1, there is a beacon for segment 2, beacon for segment 3. This one is heard only by people who are in segment 1. And it has a map only for people who are in segment 1. So it tells you, you speak this, you speak at this time, you speak at this time, and I have packet for you. So there are many beacons for each segment, and then there is basically a common beacon which is at the end of everything. So this is called DTIM, delivery TIM. In this beacon, which segments are pending data and downlink and uplink periods. So basically, this will say that, okay, segment 1 people, be careful, I have something for you. So when your beacon comes, listen for what that I have. If it says, no, I have nothing for you, you can sleep, you don't have to listen for beacon. I have nothing for you, and if you don't have anything for me, you're fine. Right? Otherwise, they have to wake up every beacon and listen whether somebody else sent me anything. Right? So the DTIM, delivery TIM, has something about each segment. And then when you go to this segment, then you can listen to it and act accordingly. So let's see if we covered all the points. Announcing all buffered frame in each beacon. An AP segment, the TIM station in segments announces only one segment at a time. And every delivery TIM interval announces which segments are pending data for uplink and downlink. So you see this big period, and then there are 1, 2, 3, 4 segments at most. I could have put one more, 4. But basically that's what it is. Okay. So this is a DTIM beacon. Actually, this is a DTIM beacon, has a beacon also. So DTIM beacon is actually, so there are 4 beacons already. Page 1, page 2. Actually, let's call it page 0, page 1, page 2, page 3.
That page 0 consists all the stations?
No. Page 0 is page 1 actually. I mean, we count from 0 to 3 and not from 1 to 4. Now, there is something different here. So this one is page 0 beacon plus something in dark blue. That field is not there in other beacons. That is called segment count information element. That has that, okay, segment 0 you have something, segment 1 you have something, segment 2 you have something. So just extra field in that beacon. 0 is not all the stations. Yeah.
Because you said that stations will be divided into different pages. So each page will listen to their specific beacon.
Yeah.
But you said about the DTIM?
Yeah, that 0 will listen and everybody else will listen.
Yes. So it goes for all the stations.
Okay, so that way it is correct. It is correct. It is correct. Okay. So, okay, let me say this one. So DTIM goes to all the stations, but it has the map only for segment 0. And it has a segment map for all the segments. Clear? So that has a segment map which is not there in other ones. So you're right actually. What is happening is that if you're lucky to be in segment number 3, unlucky to be in segment number 3, then you have to listen to this and that. Wake up twice. Well, you have to listen to one only basically. If you have something waiting, then you have to listen to both. Right? Segment 0 has to listen to 0 and that's it, done. But most stations, they just wake up on TIM stations. They wake up if they have something to transmit or if there is something waiting for them which they know from the beacon, from their own beacon, but they can know from DTIM whether they have to listen to their own beacon or not. Alright, so let's go back to where we were. Channel access for TIM. Each station knows what segment they belong to. So station wake up every DTIM interval and find out which beacon they should listen to. The beacon has detailed map indicating which station has pending traffic and when stations can connect for access. We have said all this. If the map indicates AP has buffered packets for a station, the station uses DCF to send a PS pool to get the packet. Now, here I am using what DCF. How many people remember DCF, distributed coordination function? One? I got to take more exams then. Because you forget after the exam. So this was basic thing in BC, 11, whatever, in the beginning, distributed coordination function, right? And there was a point coordination function, PCF. If you forget PCF, I can forgive you, but DCF is, everybody should know. So DCF was the distributed coordination function, which consisted of, like some period being reserved, and then after that, some period being, available for contention. You send the RTS, you get the CTS, and you can transmit, right? That is DCF. So using that DCF, you tell the AP, okay, I'm ready, I'm awake. Please give me my packet. If you don't wake up, the next beacon will, you can wake up and you don't lose the packet, right? And you might lose the packet if you don't wake up for a few days because it will run out of time or buffer or timeout or whatever, right? So the way it is that if you find that you have something buffered, you use DCF to poll and to get it. A station has a packet to send. If it has a packet to send, then it listens to the map and uses DCF to send RTS. So in the map, in the traffic indication map, it says, okay, station 3, if you want to send something, here's the time that you can send. At that time, you send the RTS. And now it is not just reserved for you that time. That might be reserved for 2 of these people, or 3 of these people, or 4 of these people. So in that time, you might have some contention, but hopefully they were not, all of them are not want to speaking, may not be speaking. So you will get through. Okay. So what they are doing is that if all 8,000 stations try to contend with a DCF like before there was no reserved period for anybody. Right? Everybody has to just see the symbol and then, draw a random number and then check it out, right? Remember that scheme? Here, they are dividing 8,000 into 2,000 first, and in 2,000 they are dividing into small groups, okay, and then giving the group a particular slot in which they can contend, right? So now 4 stations contending in a slot is much better than 4,000 stations contending in a slot, right? So chances of success are much higher. Yeah.
So here again we have using some random numbers to...
No, so the thing is here, that's the part, is that you know that you're going to do in a slot 1. Now I don't know whether in the slot 1 is big enough to draw a random number. You have to do it in slot 1. You cannot do it in slot 2. Right? The slots might be very small, so I don't think there is any random number stuff here. Basically.
I mean, at least in the previous scheme that we had, there were no congestion, but in this one there might be congestion. If, for example, 2 stations want to transmit at that time slot.
Right. So I will have to check this out again. Is that if you did it and you did succeed, the next time when you get the same group poll, right? There must be some mechanism to reduce that from 4 to 2. Okay, and how that happens, that part be there, that you have some probability of saying, okay, I didn't succeed, so now I'm going to take a probability of half to try next time. But there is no random time interval in the sense that, so suppose you are given, let's say 4 of you are given slot number 1, and all 4 you tried, all 4 failed. Next time, all of you will try a random number between 0 and 1, and so only 2 will try, and 2 will not try. Because you got a 1, right? You got to wait. And the same slot though, you're not going, right? And then if you still conflict, then next time we'll try a number between 0 and 4.
So it's waste of time.
I know, but thing is, here is a general rule. For very heavy traffic, reservation works best. For very rare traffic, random works best, right? So if we expected that we are going to send very high, for AC for example, we expect that people are going to send very large files and videos and movies and things like that. There, random may not be the best idea. You make a reservation and you got your reserved seat. This is random and still reserved though. Why reserved? Because it's reserved for 4 of you. You don't get 1 reserved seat per person, but you get 1 reserved seat for 4 people, which is good enough. This is the thing. This is very low traffic. We don't expect this to be used 100% of the time. All right. A small number of stations, and suppose if there's nobody wants to use it, generally most of the time, according to this, they expect that you will come and you will transmit and it will be done. So this becomes TDMA. This is like reserved. If reserved for 4 people and they are not really active, you almost get a reserved seat. That is what TDMA is, time division multiple access. Slot number 1 for you, slot number 2 for you, slot number 3 for you. That's the kind of thing.